Good morning, geometry class. Hope everybody's doing well this morning and got everybody's homework. Did a great job there getting all that in. Today, we just want to quickly get into our review of our homework. We just want to make sure everyone did those right. So page 34 yesterday for homework was page 34, 6, 8, and 10. And then page 36, 4, 6, and 8. So quickly go over those, and then we're going to get into our new topic. I want to remind you that you're continuing to memorizing your formulas from the first section, second section. All those are going to be building. You need to make sure you know those for the self-test and for the PACE test. So should already be memorizing them, continue to memorize them, and being prepared for the self-test and the PACE test. All right, so that's just upcoming in just a few days. So we start preparing for that. All right, so yesterday, quickly by way of review, we looked at the area of a sphere, and then we looked at the volume of a prism, the area of a sphere and the volume of a prism. So let's just quickly go over those on the board for our homework, and then we'll go on. So number 6. For number 6, we just had a soccer ball there. We have a radius that's given to us, which is 11 centimeters. So the area of a sphere is, again, the total area is 4 times pi times r squared, or r squared, excuse me. And then you want to make sure that your answer is expressed in units of pi, in terms of pi. So we're not going to use the numerical value of 3.14. We're just going to express the value in terms of pi. So for number 6, make sure your answers are checking out. 484 pi centimeters squared. 484 pi centimeters squared. For number 8, 252 pi centimeters squared. And number 10, 7.56 pi kilometers squared there. Number 10, obviously you had to find a half of 2.75. So 2.75 divided by 2, and then you put that into the formula, and it'll be 4 times pi times that. So whatever you get for that, I believe you should get the answer 7.56. So we won't go over that. Just make sure that your answers are correct. For page 36, number 4, 6, and 8. 4, 6, and 8 on page 36. So for number 4, we had the volume of each prism. So the volume now, once we're looking for the volume, you want to make sure that your answers are expressed in cubic units. So cubic centimeters, cubic meters, and different things like that. So you want to make sure that you're aware of that. So 36, number 4. 36, number 4, the answer is 112 centimeters cubed. 112 centimeters cubed. For number 6, the answer is 1,200 meters cubed. 1,200 meters cubed. And for number 8 is 120 centimeters cubed. So that was your homework. I hope everyone did well with that. Okay, so let's quickly turn to page. Page number 37. We're going to continue what we were looking at yesterday. Here is the volume of a cylinder. The volume of a cylinder. So the volume of a cylinder is volume equals, okay, want to highlight this in your textbook and memorize this. So volume equals pi r squared h. Pi r squared h. And then want to make sure that you, again, take your time with these. So let's look at number 17 together. Okay, number 17. Okay, we have a cylinder here. So we have 8 centimeters is our altitude. And then we have a radius of 4 to the square root of 5. Okay, and I'm just simply going to plug this into our equation here. So volume equals, again, we're just going to leave it in terms of pi. So express in terms of pi again. So pi times 4 to the square root of 5 centimeters squared times the height, which is 8 centimeters. Okay? Now, class, I hope you remember again, once we have an exponent, we're going to raise this to the power of 2. What happens inside the parenthesis? So we want to square the 4. So 4 times 4 is 16. And then what happens with the radical sign when we have an exponent? Very good, it removes. So we have 16 times 5 centimeters here, okay? And then times 8 centimeters. Now, okay, let's quickly get our calculators out here. So we have 16 times 5 times 8. So 16 times 5 times 8. The answer is, all right, get a calculator. I'll let you do that for a second. Then you can give me the answer. 640 pi centimeters cubed. All right, very good there. Pi centimeters cubed. So again, making sure you're understanding how to take care of radical signs with your exponents, and simple there, right? So let's go on and do number, that was number 17. Let's do number 19. Let's do number 19 together. Okay, so for number 19, okay, and so we have our altitude here. So our altitude is 12 meters, and our radius is 2.3 meters. Again, just matter of fact, just plugging into the equation and chugging out the answer. So volume equals pi r squared, so 2.3 meters squared times the height, which is 12 meters. Okay, 2.3 meters times 2.3 meters is 5.29 meters squared times 12. All right, 5.29 times 12 will give me, again, we're going to express these answers in pi, so 63.48 pi meters cubed. We'll do one more for practice, and then you guys can go on and do your own. Okay, so let's do number 21. All right, let's do 21. Okay, we have our altitude, which is 9 meters, and our radius, which is 8.9 meters. I'll give you a few seconds. Why don't you plug that into your calculator and then give me the answer. Okay, class, your answer should be 8.9 squared times 8.9 squared is and your final answer, you should have for your answer 712.89 meters cubed. Real simple, following the formula for the volume of a cylinder, the volume of a cylinder, okay? So let's turn the page now. We're going to go, actually for homework on page 37, mark these down. I want you to do 16 and 18. 16 and 18 on page 37 for additional practice. Let's go to page 38. The volume of a pyramid. The volume of a pyramid. So I'm going to leave this up here. All right, we're going to put up here the volume of a cylinder. All right, now the volume of a pyramid, okay, the volume of a pyramid. Now, so we see here the volume of the pyramid is 1/3, again, 1/3 of the base times the height. Now, if we're looking for the area, remember we did that, it was 1/2 the base times the height, but since we're looking for the volume, again, it's three-dimensional, so the volume equals 1/3 times the base times the height. Now, I want you to draw your attention on page 38 in the reading portion, okay, at the top of your page here, okay? So we see that if we have a square base, notice if we have a square base, so if you have a pyramid with a square base, then I'm just going to write here with a square base, okay? Our base, we're going to go, obviously, base equals s squared, okay? If we have a triangular base, let's say if it's a regular triangular pyramid. Look down the last sentence there. Last paragraph. What about a regular triangular pyramid? How do we find its volume? Remember, B equals the area of the base. Since the base of a regular triangular pyramid is equilateral triangle, this goes back a few pages now, we use the formula to find the area of the base, which is, okay, so again, if it's a regular triangle here, we're going to use the area of a base. So which is going to be, base is s squared to the square root of 3 over 4. Okay, so square base, regular, triangular base, all right, equilateral triangle. So we got to take that into account, and then we can plug that in through the formula and simplify it. So let's practice these together, okay? Let's do number 3 together, all right? We're going to do number 3. Notice for number 3, we have a triangular base, okay? So that's very important for us to remember here. So a triangular base. So let's look at number 3 together. So we have, let's read the directions quickly. Round off answers to 2 decimal places. You may need a separate piece of paper for your calculation, so let's be sure to round off our answers to 2 decimal places, okay? So let's begin here. We're going to start off with number 3. All right, so volume equals 1/3 times the base times the height. Now let's look at what's given to us here. 1/3. What kind of base do we have, class? It's a triangular base. Very good. If it's a regular triangular base, we're going to use s squared times the square root of 3 over 4. So let's plug that in here. So, all right, so I'm going to go, our side is 7 centimeters squared times the square root of 3 over 4, and then times the height. Okay, so the altitude is, for number 3, 12 centimeters. Okay, let's work this out together here. So 1/3. 7 times 7 is 49 centimeters squared times the square root of 3 over 4. All right, times 12 centimeters. Okay, now let's quickly get your calculator. Let's go 49 times 12. So 49 times 12, let's just multiply these two together here. 49 times 12, which would simply be 588 to the square root of 3 centimeters cubed over 4. All right, okay, get your calculator out. What's 588? All right, times the square root of 3. So let's simplify that. So 588 times the square root of 3. So let's just go, so let me go back a little bit. Why don't I just do it longhand so you can see the steps here, okay? So I'm just going to go 1/3. I'm just going to go 588 divided by 4, okay? Which goes in evenly, by the way. So we're just going to simply reduce that, which would be 147 centimeters cubed. And then 1/3 times 147 centimeters cubed is going to be, oh, I'm sorry, messed up here. Square root of 3 centimeters cubed. Okay, and then 1/3 times 147 is 49. 49 to the square root of 3 centimeters cubed, and then we want to simplify that to decimal, so 49, and then what is the square root of 3? Punch that into your calculator, and you should have your final answer of 84.87 centimeters cubed. Okay, so very important, working through this process. I want to leave the work down there for you. So that is it. We have a regular triangular base, so you want to make sure that you use that function there. And then let's see for number 5. All right, number 5, notice for number 5 we have a square base. So we're going to change this. Okay, so since we have a square base, we're just going to go s squared. Okay, so volume equals 1/3, okay, times the base, which is s squared. So I'll just going to write it in there, times the height. So 1/3. Now, what is the side? So we're looking at number 5 on your page there. So the side would be 5 meters squared, and then times the height, which would be 8 meters. Okay? So 1/3 times 25 meters squared times 8 meters. Okay? And then 25 times 8 would be 200 meters cubed. And then times that by 1/3. And your answer should be 66.67 meters cubed. 66.67 meters cubed. All right, so that's the volume of a pyramid. The volume of a pyramid. We'll do one more for practice. All right, so we'll do number 7 together, just to work that out, and then we'll move on here, okay? Okay, so for number 7, just quickly look at the base of these problems. All right, is it a square or a triangular base? Good, it's a square base, so I'll be using S squared. So, okay, so 1/3 times 4 millimeters squared times the height, which is 9 millimeters. So 1/3 times 16 millimeters squared times 9 millimeters. Okay, so we get that. Then 16 times 9 is 144 millimeters cubed, and then times 1/3 we should have 48. Again, sorry about that. Somebody called my phone and kind of knocked us off, so this is part 2. So we just finished page 38. We're actually going to do it at page 39 now. We're going to look at 2 of the story problems there on page 39. All right, so let's look at number 9 on page 39. The Great Pyramid of Egypt is a square pyramid, originally 147 meters tall, with a base edge of 230 meters long. What was its original volume? So again, all we need to know, the key there is what kind of base does it have? It has a square base. So volume equals 1/3, right? S squared times H. So volume equals, so we're going to look at that. All right, so 1/3. Now, what is the length of the side? So again, let's reading that together. We see that it is 147 meters tall with a base edge of 230 meters long. So, all right, the side would be 230 meters squared, and then times the height, which would be 147 meters. Okay, so 230 squared would be 52,900 meters squared. Okay, now simply 52,900, get your calculator out, times 147. That's going to give me an answer of 7,776, 7,776,000, 300 meters cubed. Times that by 1/3, and your final answer should be 2,592,100 meters cubed. So real basic. Looking what kind of base it has. Does it have a triangular base? Does it have a square base? All right, let's do one more here. Let's do number 11 together. Number 11. All right, it says that the base of a triangular pyramid forms a right triangle. The legs of the triangle are 3 centimeters and 8 centimeters. If the altitude of the pyramid is 15 centimeters, what is the volume of the pyramid? So let's quickly look here. All right, so we have volume equals 1/3. Now, since we have, okay, a right triangle as our base, it's a right triangle as our base, so we have a triangular base here, so we know that the legs are not, it's not a regular triangle. So we're not using the S squared times the square root of 3 over 4. It's just a simple regular triangle. So I'm going to go 1/2 times the base times the height. Okay, and then times the height again. So this is the key here. This part of the equation here, that's just a regular triangle, the area of a triangle, which is 1/2 the base times the height. So 1/3 times 1/2. Okay, now what's the base and the height of the legs of our triangle, right? We're 3 centimeters and 8 centimeters. And then what is the altitude? Okay, which is 15 centimeters. Okay, let's quickly just get our math, do our math here. So 1/3, all right, so we have 1/2 times, okay, so 3 times 8 is 24 centimeters squared. Okay, centimeters there. All right, so 1/3. Now 24 times 15, okay. So let's go here, make that 12. So what's 12 times 15? 12 times 15 is 180 centimeters cubed. And then 1/3 of 180 centimeters cubed is simply 60 centimeters cubed. Okay. Again, the key is when you're reading these is understanding what the base is. So in our base, we had a right triangle. So it's not a equilateral triangle. If it was an equilateral triangle, then we would say, hey, it's s squared times the square root of 3 over 4. But because it wasn't, we just used the regular formula for the base of a triangle, which is 1/2 times the base times the height. All right, so let's quickly move on here. If you have any questions, again, feel free to contact me, and I'll try to work with you further if need be. Now, let's look at the volume of a cone. The volume of a cone. So, all right, thus far, the volume of a cylinder, the volume of a pyramid. Now, thirdly, the volume of a cone. All right, okay, the volume of a cone is volume equals 1/3 times base times the height. Now, what is the base? That's the key, right? So as we read on here, we have a circular base. A cone, right, with a circle as a base. So therefore, our base would be pi r squared h. So if it's a circular base. So again, just a matter of plugging in and chugging. All right, page number 40. Let's do these. Again, we're going to express answers in terms of pi. So we're going to do the evens here, okay? We're going to do the evens. So let's begin with number 14 here. Number 14 on page 40, okay? So we have a cone here with a radius of square root of 2 centimeters and an altitude of the square root of 3 centimeters. So let's quickly look at this together. All right, so volume equals 1/3 times pi, all right, times the radius, which is the square root of 2 centimeters squared, times the height, which is the square root of 3 centimeters. Okay, again, okay, the square root of 2 centimeters. Okay, we're going to square that, which becomes the square root of 4. I'll show you that. Okay. Now, we could simply simplify that. What's the square root of 4, class? 2. Okay, so 2 centimeters squared times the square root of 3 centimeters. Okay, so now we have 1/3 pi times 2 times the square root of 3. Now, since this is not under a radical sign, we can't multiply them, so we're just going to simply combine them. So 2, all right, to the square root of 3 centimeters cubed. All right, now, we just want to simplify that here. We can go 2 to the square root of 3 over 3, and then simply reduce that, okay? Simplify that. So what's 2? Find the square root of 3, class. Okay, find the square root of 3, times that by 2, divide it by 3, and your answer should be 1.15 pi centimeters cubed. 1.15 pi centimeters cubed. Okay, so that's number 14. Let's do number... I think I did your homework problem. Oh well. All right, so let's do we'll do number 18. Number 18. Okay, number 18. All right, we have a radius of 3.7 millimeters and a height of 12.2 millimeters. So let's quickly, all right, plug that in. So volume equals 1/3 times pi times the radius. So the radius is 3.7 millimeters squared times the height, which is 12.2 millimeters. Okay, give you a few seconds. I want you to work that out and give me your answer. Okay, your final answer should be, all right, once we square the 3.7 times that by 12.2, then multiply that by 1/3, your final answer should be 55.67 pi millimeters cubed. If you got that, you did a great job there. And real basic. It's just a matter of plugging in our numbers and chugging out the answer. Make sure you just take your time there. For homework on page number 40, I want you to do 13, and I want you to do 16. 13 and 16 for homework, okay? And let's turn the page, and we'll close with this last page here, page 41, which is simply the volume of a sphere. Okay, lastly, the volume of a sphere. So the volume of a sphere is simply volume equals 4/3 times pi times r cubed. Okay, that's it. The sphere is a very common shape. The sun, the moon, the earth are spheres. Many sporting events use balls that are spheres. The formula for finding the volume of a sphere is 4/3 times pi r cubed. Okay, and we'll just do the first one together. So we have a sphere with a diameter of 24 centimeters. So if it's a diameter, remember, how do we find the radius? Good, we simply divide that by 2. So, all right, so volume equals 4/3 times pi. Again, express answers in terms of pi. Now, in this answer, okay, in this problem, the directions state use 3.14 for pi. Okay, the round off answers to 2 decimal places. All right, so let's do that. 3.14, and then our radius is going to be 12 centimeters, and we'll cube that. Okay, so looking at this problem here, get your calculator out. So 12 cubed is, okay, all right, 1,728 centimeters cubed. All right, let's quickly multiply 3.14 times that. So 3.14 is 5,425.92, and that were centimeters cubed, and then times that by 4/3, and your final answer should be, really big answer here, 21,489,963,750. Oh, sorry. I read the wrong problem. I'm already on a different problem here. So forgive me. 7,234.56 centimeters cubed. I was jumped ahead and did the next problem. All right, so forgive me about that. So, all right, so here we go. Just a matter of plugging into numbers and chugging. Here's the thing that you're going to have to do. You're going to have to memorize these formulas. So you should have been memorizing them since the very first time we started this pace. If you have been, you'll not have a hard time. Understanding, especially when we get to these polyhedrons, prisms, and pyramids. Understanding, how do I see, there's so many different scenarios. Look at the base. We have a rectangular base, we have a square base, we have a triangular base. And so when we're finding those areas and those volumes, understanding if I look at the base, that determines what equation I will be using when we're looking for the total area and the lateral area. All right, so make sure your homework is turned in. Again, and then lastly, page 41, number 2 for homework. Page 41, number 2. You want to prepare. Tomorrow we'll be taking the checkup. So you'll be taking the checkup tomorrow, and then we'll be preparing to take the self-test on Friday. Okay, so study hard, work hard, and we'll see you tomorrow.